This is the third video covering chapter 10 now. The null and the alternative hypotheses are given. Determine whether the hypothesis test is left-tailed, right-tailed, or two-tailed. That's very easy to tell you. Just look at the alternative, which is H1. If the sign is greater, it will be right-tailed. If the sign is less, it will be left-tailed. If the sign is not equal to, it will be a two-tailed. So it is a right-tailed. What are we testing here? Well, you can see a sigma, which is called the population standard deviation. For students who first enroll in two-year public institution in a recent semester, the proportion who earned a bachelor degree within 6 years was 0.385. The president of a certain college believed that the proportion of students who enroll in her institute have a higher completion rate, so more than 0.385. What's the null in the alternative? Remember, the null is always an equal sign, so 0.385. And since they're making the claim is the proportion is higher, we just put the greater sign. What is a type 1 error here? He's asking you to identify type 1 error. Type 1 error means you reject the null hypothesis when it is actually true. So let's see which statements say that. The president rejects the hypothesis that the proportion is who earns bachelor degree with 6 years is 0.385. So that would be the answer, when in fact it is a true statement. What does it mean to make a type 2 error? Type 2 error means you fail to reject the null hypothesis when it is actually false. So the president fails to reject the hypothesis that the proportion of students who earn a bachelor degree within 6 years is 0.385, when in fact the proportion is greater than 0.385. So when you fail to reject the null hypothesis when it is false, you make a type 2 error. The mean of the pressure required to open a certain valve is known to be 7.1 psi. Due to changes in the manufacturing process, the quality control manager feels that the average pressure has increased. So actually here, so the mean is believed to be 7.1, but the quality control managers feels that the average has increased. The null hypothesis was not rejected. So we failed to reject HO. What can you say about the claim? If you fail to reject the null hypothesis and your claim happened to be in H1, you say there is not enough evidence to support the claim. So let's see which statement would work here. There is not sufficient evidence that the mean of the pressure required has increased. Okay. Select the correct choice that completes the sentence below. The null hypothesis denoted HO is a statement to be tested and a statement of no change. That's why we have the equal sign always in the null hypothesis. No effect or no difference. According to a report, let me just hide the answers so then we can figure them out. According to a report, the standard deviation of monthly cell phones was 6.72. A researcher suspects that the standard deviation is less today. Less means less than. So standard deviation, you have to pick sigma, not mean, not proportion. And this is always equal in the null hypothesis. But he says it's less today. You just choose this, and that should be your answer. The other parameters, P is for proportion and mu is for mean. Remember that. Test the hypothesis using the p-value approach. Be sure to verify the requirements of the test. Okay, HO, the null hypothesis P equals 0.8 versus H1 P greater than 0.8. He gives you N, he gives you X, and he gives us alpha. Okay, here's how you do this on the calculator. You don't need to do this by hand. So we are testing the proportion. It is called the proportion Z test. So you go to Stat, Tests, and it's number 5. Enter. Okay, P0, you enter the value in the null hypothesis, which is 0.8. X is the smaller value, which is 210. N is 250. Proportion, okay, what's the sign in the alternative? It's a greater than, so you have to select this one, enter, and then hit calculate. So Z0 is 1.58, so you just enter 1.58 here. 1.58. The p-value, he says, to 3 decimal places. What would that be? 0.057. And alpha is what? 0.1. Well, you know 0.057 is less than 0.1. If p-value is less than alpha, we reject the null hypothesis. If p-value is more than alpha, we fail to reject the null hypothesis. So we're going to reject the null hypothesis because p-value is less than alpha. And that should be it. See, got 100%. Next question. Test the hypothesis using a p-value approach. Be sure to verify the requirements of the test. Okay. The null hypothesis p equals 0.6 versus h1 p greater than 0.6. Very similar to the one that we did earlier. So here's how we can verify the requirements of the test. So to check the requirement, this is how you do. I just refreshed the page, so I got a different problem. N is 200, P0 is a 0.2, and 1 minus 0.2. You multiply them. If you get a number greater than 10, then your answer should be a yes. Now find the p-value. We're going to go and do the proportion z-test. You can see you don't have to do the p-value by hand. Enter. So 0.2 right here. X is what? 45. N is 200. And now the sign from H1, which is what? Greater than. So you select that one. Make sure to be select and press enter and hit calculate. And here you go. Z is 0.88 and the p-value is 0.1833. So your p-value is 0.188. You just put it there. And if it is more than alpha, it is more than alpha. So you fail to what? Do not reject the null hypothesis because the p-value is what? Greater than alpha. A certain drug can be used to reduce the acid produced by the body and heal damage to the esophagus due to acid reflux. The manufacturer of the drug claims that more than 92% of patients taking the drug are healed within 8 weeks. In clinical trials, 216 of 232 patients suffering from acid reflux disease were healed after 8 weeks. That's the claim. Okay, so he's asking us here an additional question to verify the requirement. And here is the answer. So NP0, it's against P0 is 0.94. And N is how many? We have 230. So 230 times 0.94 times 1 minus 0.94 will give you 13. If the 13 is bigger than 10, that verifies the requirement. And you always have to use this. This is fixed for all problems. The sample size should be less than 5% of the population size. The samples can be assumed to be always random, so the requirements for the test are met. What is it that we need to test? We need to test that more than 94%, so you can see why P is greater than 94%, and here's how you do it. So you go to Stat, Proportion Test. We're still doing proportion. This is section 10.2. Enter. 0.96 is the value from the null hypothesis. Oh, not 96, is 94, sorry. So I said earlier 96, but I meant 94%. X is 218. N is 230. P is greater than the sign in the alternative hypothesis. You always, this is the sign in the from the alternative, and then you hit calculate. So Z is 0.4997. If you round it to 2 decimal, it will be 0.5. P-value, as you can see, it's 0.309, which is bigger than alpha. And if it is bigger than alpha, you fail to reject the null hypothesis. And if you fail to reject the null hypothesis, there is not enough evidence to support the claim. Okay? So that's how you do this. Next. Here is another question again for the proportion. Previously, 7.5% of workers had travel time to work for more than 60 minutes. And urban economists believe that the percentage has increased since then. So P, it's going to be P equal 0.075 if you want to change it to a decimal. And here it's going to be P what? Greater than, because that's the claim, 0.075. And again, to verify the requirements, you take the 0.075 multiplied by N. Okay. Believes that the percentage is, she ran with 65 workers, so N is 65. And then you multiply by 1 minus 0.075. And let's see what the answer should be here. So if you do the math, it's going to be 7.4 less than 10. And if it is less than 10, then you will not be able to use the one proportion Z test in order to perform an hypothesis test. So just skip this exercise, don't worry about it, because it doesn't meet the requirements. Now we're going to section 10.3 to test HO mu equals 20 versus H1 mu less than 20. A simple random sample of size n equals 18 is obtained from a population that's known to be normally distributed. Answer parts A through D. If X bar is 18.5 and S is 4, what's the test statistic? Okay, here's how you find it on the calculator. You go to tests. Okay, it's a t-test. It is a t-test because he gives you S instead of sigma. You only use z-test when sigma population standard deviation is known, but in this case it's S, so it's a t-test. And watch. You go to stats. Okay, mu 0, it's 20. The value from the null. X bar is 18.5. S is 4. And N is how many? He says 18. And what are we testing? Less than 20. So the sign will be less here. And hit calculate. Enter. Okay, so T is negative 1.591. Here you go, guys. You can see it. Draw a t distribution with the area that represents the p-value. Well, since this is a left tail test, it's a less than, the p-value should be on the left, so that should be your answer. What is the p-value? The p-value is right here, 0.065. Okay, where would the 0.065 fall? Choose one of those answers. Well, 0.065 falls between 0.05 and 0.10. You choose this one. If the researcher decides to test the hypothesis at alpha equals 0.05, so alpha is 0.05, and I got 0.065, which is bigger than alpha, so we fail to reject the null hypothesis. You see, the researcher will not reject the null hypothesis. Okay, so that's complete the question. Next question. A college entrance exam company determined that a score of 24 on the math portion of the exam suggests that a student is ready for college level. To achieve this goal, the company recommends that students take a core curriculum of math courses in high school. Suppose a random sample of 200 students who completed this core set of courses result in a mean X bar 24.3 on the college entrance exam with a standard deviation of 3.7 S. Do the results suggest that the students who complete the core curriculum are ready for college level mathematics? Okay. That is, are they scoring above 24 on the math portion of the exam? So we need to test the claim that the mean is more than 24. You can see here mean is more than 24 and the null is always the equal sign. What are the conditions of the t-test? The samples size must be larger than 30, or the population has to be normally distributed. The students' test scores are independent of each other, which is the case here, and the students were randomly sampled. It has to be a random sample. Okay, use the p-value approach to test this claim. So we're gonna do it on the calculator. Stat, tests, t-tests again, and we're testing against the value 24. We're trying to see if the mean is more than 24. What did he say? X bar 24.3. And what did he say? The standard deviation was 3.7. And the sample size is huge, 200. And we're testing if the mean is bigger than 24. So we go to the third one and select enter. And let me hit calculate, enter. So t is 1.146. If you round it to 2 decimal, 3 decimal will be 1.15. And look at the p-value, guys. It's 0.126. It matches right here. This is bigger than alpha. We fail to reject the null hypothesis, and we say there is not enough evidence to support the claim. Okay. Next question, pretty much the same. You won't get as many questions on the test, but this is a study guide, so I try to include as many as possible. So in a study, researcher wanted to measure the effect of alcohol in the hippocampal region, the portion of the brain responsible for long-term memory storage. In adolescents, the research randomly select 11, so N is 11, with alcohol use disorders to determine whether the hippocampal volumes in the alcoholic adolescents were less than normal volume of 9.02. So we want to check the claim that the mean is less than 9.02. You can see it here, less than, and the equal. Again, as usual, it's equal. Analysis of the sample data revealed that the volume is approximately normal with no outliers. X bar is 8.02, S is 0.8. You see, once he gives you S, it's a t-test, guys. Link it to a t-test. Conduct the test at 0.01 level of significance. So you just go to stat, tests, t-test. U0, we're testing against 9.02. X bar is, what did he give? 8.02. S is 0.8. N is how many? 11. And we're testing that the mean is less. The alternative sign is less than. So you have to select less. Don't forget, you have to select and press enter. And let's hit calculate. So t is negative 4.145, which is negative 4.15. P-value, look at 0. It's 9.96 e minus 4. E minus 4 means you have to move the decimal point 4 digits to the left. So it's 0.00099, which turns out to be 0.001 if you round it, which is less than alpha. And if it is less than alpha, you reject the null hypothesis and you support the claim. When you reject the null hypothesis and the claim is in H1, you support the claim. There is sufficient evidence that the mean volume is less than 9.02. Another question on testing the mean. A golf association requires that golf balls have a diameter that is 1.68 inches. So equal. That is means equal. To determine if golf balls conform to the standard, a random sample of golf balls was selected. Their diameters are shown in the accompanying data table. Oh, right here. Do the golf balls conform to the standards? So equal and not equal. You don't need to type in the data if you don't want to use the calculator. Just we're gonna click and take you to StatCrunch here. So I click on open in StatCrunch, and then we're gonna go to stat, t-stat. It's a t-test, always one sample. Oops, sorry. T-stat, one sample with data. I have the data here, so with data, it's the data is the diameter, and we're gonna run a hypothesis test. And what's the value that he's asking us to test against? He says if it used to be 1.68 and we want to check if it is still 1.68. So you put 1.68. And if this is equal, this one is not equal. So we'll just use not equal and compute. Probably you don't see the compute button, but it's right here. Just hit compute. And here's the test statistic. It's 0.7385 and the p-value is 0.4756. So let me just clear this and show you. These are the values. I'm going to clear that. 0.476, as you notice, the p-value. The other way you can do this is click, go to stat, enter, put the data in L1, go to stat, tests, t-test, mu0 changes to 1.68, and then, oh sorry, you have to choose data there, enter, I'm sorry, and now 1.68, make sure this list is L1, you have the data in L1, don't change the frequency, and we need not equal here, and then hit calculate, and you're gonna get the same test statistic and the p-value that we got. Since the p-value is more than alpha, we don't reject HO. And if we don't reject HO, that means HO could be correct. And they say the standard should be 1.68, so that's a conclusion. There is not sufficient evidence to conclude that the balls do not conform to the association standards at the 0.05 level of significance. Determine whether the following samples is independent or dependent. Indicate whether the response variable is qualitative or quantitative. A researcher wishes to compare annual salaries of wives of pharmacists and other wives. Well, if it is, there are two different groups, wives of pharmacists and other wives, so the samples must be independent. Dependent, it will be the same person before and after some action. Now, she obtains a random sample of 885 wives of each category who work and determine each wife's annual salary. Now, indicate whether the response variable is qualitative or quantitative. It is quantitative because we're talking about annual salary, which is a number. So this covers chapter 10, so there will be a last video covering chapter 11.